In this video, we will be seeing about what is meant by PN junction diode and the construction and its characteristics. So, in this video, we will be discussing the following topics. So, what is PN junction diode, how it is formed, what are the different types of biasing available for the diode, and the VA characteristics curve and the practical applications of the PN diode. So, coming to our first topic, what is meant by PN diode? It's just before going to what is meant by PN diode, why we need a PN diode is an important question. So PN diode is something, it's a building block of all our electronic items. So basically by its understanding its behavior, we will be able to understand why it is essential for analyzing the rectifiers, regulators, LEDs, sensors, etc. So the construction of the PN diode, as shown in the diagram, if it is made up of P-type semiconductor and N-type semiconductor. The P-type semiconductors, P-type material will be having empty holes and N-type material will be having free electrons. So these two different semiconductor has been doped together into a single crystal to form the PN junction diode. So the formation of the depletion layer plays a major role in the conduction of the PN junction diode. So the PN N regions are joined together, as we know, in order to make a PN junction diode. So on a small amount of power given, the P region have holes which will move towards the electrons, and the N region will have the electrons which will move towards the hole, combine together and forms the depletion layer. So based on the depletion layer width, the connection will be the flow of electricity will be there. So in ideal state, so no current is in ideal state, when no biasing is being taken place, the PN junction diode will not conduct any current conduction between the diodes. So consider in forward bias where the positive of the battery is being connected to the P type and the negative of the battery is being connected to the N type. So the battery induces the electric field. So the built-in electric field is being produced, and the electrons and holes will move towards each other in order to form the depletion layer. If we see the depletion layer, it is very thin, so the connection will be the flow of electric field will be very high. The electric current flow will be very high in the case of forward biasing. In case of reverse biasing, the positive is connected to the N-type material and negative is being connected to the P-type material. So there will be no flow of current. The minimal amount of current will be only flowing in case of reverse biasing. So based on the reverse biasing and the forward biasing, the VI characteristics curve of a PN junction diode can be explained. So if you see the graph, after a point, in the forward voltage, that is when the positive is being connected to the P-type material, the forward biasing will be taken place. So if we consider the graph, after a few point, the graph is being increasing in a steady state. That particular point is called as knee voltage, where the steady state current is being achieved. If we see the reverse leakage current, the small amount of current is being there in the reverse bias, and there also the breakdown, after the breakdown voltage, the graph follow a steady state flow of current. So the practical application of the PN junction diodes are, they are used in the rectifiers and voltage regulators, photodiodes and solar cells, logic gates and digital circuits, switching circuits, LED and laser diodes. So on a summary, in PN junction diode, we have seen we have two biasing, forward and reverse biasing. In forward biasing, the current flow will be there, low resistance will be found, the depletion layer is very narrow, and in case of reverse biasing, the high resistance will be there, no significant current is there, the depletion layer widens. So in this video, hope you would have understood what is meant by PN junction diode, what are the practical application of PN junction diode, where it is being used, and the various types of biasing conditions, and what are the results we achieved using through that biasing condition. Thank you.